Hey everyone, in this video we're going to learn how to solve two-variable inequality word problems. Our directions: write and graph an inequality to model each of the following situations. First up, Justine is buying flashlights to put in hurricane relief packages. She can either buy them individually or in packs of 4. She wants to buy at least 12 flashlights. With any word problem, the first thing we need to do is define our variables. So we'll let x be the number of individual flashlights. So the number of individual flashlights. And then we'll define y to be the number of 4-pack of flashlights. So we've defined our variable. Now we need to set up the inequality that would model what we've been given. So the amount of flashlights that she would buy, well, she can either buy individual, which would be x, or 4 packs. So if she buys y 4 packs, we have to multiply by 4 to get the number of flashlights that she's bought. So we'd have plus 4y. And she wants this quantity to be greater than or equal to 12. So we define our variable, we set up our inequality. Now we need to figure out how to scale our axes so that we get a nice graph. So let's find the x and the y intercept of this inequality. So the x-intercept, the point where y is 0, I'm going to turn it into an equation, right, and just find the x and the y-intercept of the line that would be part of this solution set, or that inequality. So we have x plus 4 times 0 equals 12. So x equals 12. And then our y-intercept, reminder, is a point whose x-coordinate is 0. So we have 0 plus 4y equals 12. So if we divide both sides by 4, y equals 3. So we need 12, 0 to fit on our axes, and there are 10 boxes here. So we'll scale by 2. So we'll go 2, and then 4, 6, 8, 10, 12, 14, 16, 18, 20. I like to skip just so it's not too much going on with each axis. And then up the y-axis, 0, 3, we just have to scale by 1. So we'll go 2, 4, 6, 8, and 10. So each box is 1. Now we need to label what each axis is. So the x-axis is the individual flashlights. We'll abbreviate that FL. And the y-axis is the 4 packs. Now we can plot both points. So we have 12, 0, and we have 0, 3. And now we need to practice graphing an inequality of two variables. So the first thing we have to decide is, do we connect these 2 points with a solid or a dashed line? So we look at our inequality sign. It's greater than or equal to. So we have equality. That means that we're going to connect our 2 points with a solid line. So we'll do that now. Connecting with a solid line. And then we have to figure out where to shade our solution set. Above the line or below the line. Now, intuitively, we should be shading above the line. Right? Think, she wants to buy at least 12 flashlights. She could buy way more than 12. So any combination of flashlights up here is going to be greater than or equal to 12. But let's say we're not sure, right? We're second guessing ourselves. So let's refresh our memory how to use a test point. We'll use the origin, 0, 0. So we have our test point. So we're going to plug the origin into the inequality. So 0 plus 4 times 0 is greater than or equal to 12. So 0 plus 0 is 0. So that's not true. 0 is not greater than or equal to 12, which means the origin is not part of the solution set. Now, if that's the case, we don't want to shade below the line because that would include the origin. So that means we are going to shade above the line. So if we were looking for a combination of flashlights that satisfied Justine's goal, pick any point in the solution set in the shaded area, right? So for instance, 16, 5. That combination of 16 individual flashlights and 5 4-packs would satisfy her goal of buying at least 12 flashlights. Next up, Alex has at most $60 to spend on soda and guacamole for her birthday party. Soda costs $2 a bottle and guacamole costs $6 a jar. With any word problem, starting with our let statement. So we'll let X be equal to the number of soda bottles. And we'll define Y to be the number of jars of guacamole. We'll just abbreviate that guac. So we've defined our variable. Now we need to set up our inequality. So how much is she going to spend? Well, she's going to spend $2 on every bottle of soda, so that's going to be 2x. She's going to spend $6 on every jar of guacamole, so that's going to be 6y. And she needs that total to be less than or equal to 60, because that's the amount of money that she can spend. So we have our inequality. Now we need to figure out how to scale our axes. And we'll go do that by finding the x and the y-intercept again. So the x-intercept, when y is 0, we'd have 2x plus 6 times 0 equals 60. Again, just turning it into an equation for these computations. So 2x equals 60, x equals 30. So 30, 0. And then we have the y-intercept, which is when x equals 0. So 2 times 0 plus 6y equals 60. 6y equals 60. Divide both sides by 6. Y would be equal to 10. So on the x-axis, we need to fit the point 30, 0. So scaling by 5s I think would work nicely. So every 2 boxes is going to be 10. And on the y-axis, we don't have to scale at all. We can just go by 1s. So I'll go every 2 boxes, I'll label 2, 4, 6, 8, 10. So every box is 1. We need to label what each axis represents. So x-axis represents soda. Y-axis represents the guac. And now we can plot our 2 points. So 30, 0 and 0, 10. We need to decide if we're connecting that with a solid or a dashed line. So we look at our inequality sign. It's less than or equal to. So that tells me we have a solid line connecting the 2 points. And now we need to figure out where to shade for our solution set. Now again, we can do a little bit of reasoning here. If she has at most $60 to spend, any combination of soda and guacamole below the line should be less than $60. But again, let's say we're not sure, then use that test point of the origin again, because the origin is not on the line. So plugging that in, we'd have 2 times 0 plus 6 times 0 is less than or equal to 60. So 0 plus 0 is 0, less than or equal to 60, so that does work. And that should make sense. If you go to the store and buy nothing, you don't buy any soda or any guacamole, then you spent less than $60. So we're going to shade all of the points below the line. And there we have our solution set. Any combination of soda and guacamole in this shaded region will make sure that Alex spends less than $60. Now, any point on the line, on that edge, she's spending exactly $60. So it says state 3 different combinations of soda and jars of guacamole that Alex can buy. So let's pick this point here. So that's the point 10, 3. So that would be 10 bottles of soda and 3 jars of guac, we can pick a point on the x-axis. So let's say right there. So she can just buy 20 bottles of soda and 0 jars of guacamole. Or flipping it around, let's pick this point here. She can buy 0 bottles of soda and 5 jars of guac. Now, there's plenty other combinations that we could have stated, but this is 3 of them. Now, it does allow us to talk about a couple of things, though. First, why are we only focused on the first quadrant, on the positive x-axis and the positive y-axis? Well, in the context of all these word problems, no other part of our axes would make sense, right? It wouldn't make sense to have negative bottles of soda or negative jars of guac. So that's why for these word problems with these inequalities, we restrict ourselves to just the positive x, the positive y axes in the first quadrant. Now, the second thing, we've shaded an infinite number of points in this region, right? In this green shaded area. But not all of them make sense in the context of this problem, right? For instance, the point 12.5, 0.5 is definitely in the solution set. But that wouldn't make sense as an answer to the follow-up question because we can't go to a store and buy 12.5 bottles of soda or half a jar of guacamole. So we have to be careful when we're looking at the solution set when we're answering a follow-up question. Okay, our answers have to make sense in the context of the problem, right? We use the math to help us come up with a reasonable answer. A high school football team is selling $5 student tickets and $8 adult tickets to their homecoming game. They want to make more than $4,000 from selling tickets to the game. Start by defining our variables. So we'll let X be the number of student tickets and Y will be defined as the number of adult tickets. So to figure out how much they make, we would multiply each student ticket by $5, so 5x. Each adult ticket is going to be multiplied by $8. And the football team wants to make more than $4,000, so greater than 4,000. Now to figure out how to scale our axes, let's find those intercepts. So the x-intercept, when y is 0, we have 5x plus 8 times 0 equals 4,000. So we'd have 5x equals 4,000. X is equal to 800. Okay, so we have 800 comma 0. And then our y-intercept, when x is 0. So we have 5 times 0 plus 8y equals 4,000. 8y equals 4,000. Divide both sides by 8, and we get 500. Now, just want to point out, in this particular inequality, we have strict inequality, right? Greater than. But I still turn it into an equation to find the x and the y-intercept because this greater than is just going to affect how we draw the line, but there's still going to be a linear part of our solution set. Okay, so I made it an equality to find the x and the y-intercept just so we didn't have any crazy issues solving. So we have to scale our axes to fit the point 800, 0, and 0, 500. So I think we should scale each box by 100. So this would be 100 and then 200, 300 and then 400, 500, 600, 700, 800, 900, and 1,000. And the same thing on the y-axis. 200, 400, 600, 800, and 1,000. Okay, so x-axis is the student tickets. The y-axis is the adult tickets. And now we can graph our inequality. So we'll plot these 2 points. So 800, 0, 0, 500. Now looking at the inequality sign, it's strict inequality. So that means that we're going to connect our points with a dashed line. So let's do that now. I don't want there to be an arrow. Okay, so we have our dashed line between the 2 points. And now we need to figure out where the solution set is. Again, if we think about it, any combination up here is going to make sure that we make, or the football team makes, more than $4,000. Let's just run through that test point again. So test point at the origin. So 5 times 0 plus 8 times 0, is that greater than 4,000? Is 0 greater than 4,000? It is not. So our solution set is going to be all the points up here. So if the football team sells 400 student tickets to their homecoming game, what is the minimum number of adult tickets that must be sold to meet their goal? Okay, so they sell 400 student tickets. How many adult tickets? Well, the minimum, anything on this line, is not going to be part of the solution set. It's actually kind of hard to figure out based on our scaling. So what are we going to do? Well, don't forget, we still can solve this algebraically. So we can plug in 400 for x plus 8y. And now we just solve this inequality the same way that we would. So we'd have 2,000 plus 8y is greater than 4,000. 8y, so subtract 2,000 on both sides. 8y is greater than 2,000. Divide both sides by 8. And we have y is greater than, let's get the decimal here, use the calculator. So 2,000 divided by 8, well, goes in nicely, 250. Okay, so y has to be greater than 250. So what is the minimum number of adult tickets that they have to sell? They have to sell 251 adult tickets. Now going back up to the graph, 250 is about where we thought this was at based on our scale, but just to be sure, it was good to do the algebra. One more example. Rob wants the number of angelfish to be at least 2 more than 4 times the number of goldfish in his tank. So let x be equal to y be equal to. So the number of angelfish is defined in terms of the number of goldfish. So we'll let x be the number of goldfish. And y be the number of angelfish. So Rob wants the number of angelfish, so he wants y to be at least, so greater than or equal to, 2 more than 4 times the number of goldfish. So 4 times the number of goldfish, and then 2 more than that, so plus 2. So this inequality definitely doesn't look similar to the inequalities that we got in the earlier word problems. This looks more like a traditional linear equation word problem that we did earlier. But now, because it's at least, it turns it into an inequality. So if we were to graph this, we would use the slope and the y-intercept, which is the point 0, 2. So if we want to get a few points on our graph, let's scale the y-axis by 2. So we'll have 2, and then 4, 6, 8, 10, 12, 14, 16, 18, 20. And we'll keep the x-axis by 1. So 1, and then 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have 0. X-axis represents the goldfish. And the y-axis represents the angelfish. So now we can plot the y-intercept, so 0, 2. Now a slope of 4. Now we're not going to go up 4 boxes because each box represents 2 based on our scaling. So we'll go up 2 boxes and over 1. Up 2 over 1, up 2 over 1, up 2 over 1. Now to figure out solid or dashed, we will look at the inequality sign. It's greater than or equal to, so that tells us that we should have a solid line here. So we'll connect our points with a solid line. And now we need to figure out where our solution set is going to be. So we want y to be greater than or equal to 4x plus 2. So y is greater than 4x plus 2 at any point above the line. So we'll shade our solution set in here. And again, if we're not sure, pick a test point and we can go and plug that in. So this one's a little bit different than the problems that we had done previously, but graph the line, as long as we set up the inequality, decide whether it should be a solid or a dashed line, and figure out where the solution set is going to be. So now go and practice, do a few word problems on your own so that you feel comfortable with the material.